In general, I'm an InfoSec engineer at Ocado Technology. I have almost 4 years experience with AWS and some experience with GCP. This year, I have the pleasure of being second year AWS community builder. And in a few days, I'm going to reinforce in Philadelphia as part of the AWS All Builders Welcome Grant. So if you are going to be there as well, don't hesitate, say hi to me. So yeah, it will be nice. That's a little bit about me. So moving on to the topic, I will start with a short introduction to what Zero Trust is, and we'll focus on one of the principles of this model. I mean, least privilege. So we'll talk about policies in AWS. First, maybe let's define Zero Trust in general. So Zero Trust is a way of thinking about security and a set of tools that help protect digital information. And the main idea is we do not rely only on network protections like firewalls or the borders of our network to keep things safe. Instead, we use different methods to make sure that only the right people and devices can access our data, no matter where they are or how they connect. And what Zero Trust really means. In the past, security was mostly network-centric. We tried to protect the perimeter and trusted everything inside. Today, that's no longer enough. The focus has shifted to an identity-centric model, where we verify who is trying to access our resources, regardless of where they are connecting from. Zero Trust combines both approaches, but the priority now is on identity, making sure that only the right users and services get the right level of access. Let's smoothly explore the key principle of Zero Trust together. So the first, never trust anything by default. Always assume potential risk. So next one, grant people only the access they truly need, following the principle of least privilege. It's also essential to continuously verify who is trying to access your systems to ensure security. To further reduce risks, divide your systems into smaller, manageable segments through microsegmentation. And next one, strengthen identity verification by using robust methods like two-factor authentication. Also, keep a close eye on what's happening by monitoring activities in real time. And finally, speed up your response to threats by automating security controls wherever possible. So for today's discussion, we'll focus on the least privilege access. And let's start with IAM, AWS Identity and Access Management. So IAM definition is like it managed who can access which resources and under what conditions. So by applying this approach, we can effectively implement the principle of least privilege and adhere to the core ideas of Zero Trust. Let me see. Okay, sorry. And before we move on the more complex parts of this presentation, an IAM policy is a document that defines who can access, who can perform which actions on which resources and under what conditions. Sorry. And the first important section here is effect. which states whether the action is allowed or denied. Next one, we have principal. Principal shows who, like a user, group, or maybe rule, the policy applies to. Then we have action. Action describes what actions are allowed or denied. And resource, which specify which resources the policy refers to. And the last one, we have condition, which sets an extra requirements that must be met for the policy to apply. And here in this example, we have a principle like example user has access, like effect allow, to all resources in example bucket. But the most important requirements also is here, like he needs to use this range of IP address in condition. So let's look at how access control work in AWS environment, focusing on two main goals, categories like restrict access and grant fine-grained access. So the first one in restrict access is service control policies. So SCP are applied at the AWS organization level, and it helps limit what actions IAM rule and accounts within the organization can perform. The next one is permission boundary, which are attached to directly to IAM rules, and it restricts what those roles are allowed to do, acting as a boundary for permissions, like permission boundary, you know. And then the last one in this category is resource control policies, which also attach at the AWS organization level and help restrict access to specific resources. So these policies help us set broad limits and guardrails on what users and rules can do across AWS environments. And also here, it's I'd like to mention that RCPs we can attach directly to individual accounts, organization units, and organization root. And in the second category, grant fine-grained access, we have identity-based policies. I know you know what does it mean, but yeah, to sum up this policy, identity-based policy are attached to IAM rules or users, and define exactly what those identities can access and what actions they can perform. And the next one, resource-based policies, are attached directly to resources like S3 bucket, Lambda function, and others. They specify who or what can access the resources. So together, these policies let you precisely control access, balancing security with the flexibility our teams can need. Okay, so we'll go through a few examples of these policies and one extra example. Okay, so maybe imagine you are a user or a role in AWS with a specific set of permissions attached directly to you. So this identity-based policy says you are allowed to get object from the bucket name bucket1. So whenever you try to access any file inside that bucket, AWS checks your attached policies and sees that you have permission to perform get object on all objects in that bucket. If yes, access is granted. This means the permissions travel with your identity wherever you go in AWS. Now, we are looking at the bucket itself. And the bucket has its own policy attached to it. So the resource-based policy says anyone can get object from the public folder inside this bucket1, but only if they belong to a specific AWS organization. So instead of focusing on who the user is, the bucket controls access based on the requester's organization membership. So the bucket itself decides who can access its contents regardless of the user's own permissions. So by comparing these two, a resource-based policy are attached to the resource itself and control who can access it, while identity-based policy are attached to users or rules and define what those identities can do. Next one, SCP. So now, let's imagine our organization wants to enforce a strict rule across all AWS accounts in organization. So no resources should be created or accessed outside the EU Central 1 region. And this SCP denies all actions, but only if the requested region is not EU Central 1. So what does it mean in practice? Users and rules in any account under this SCP can perform any action, but only if it targets resource in the EU Central 1. For example, launching an EC2 instance or creating S3 bucket in EU Central 1 is allowed. However, trying to create or access resources in US East 1 or any other region will be denied by this SCP. And now, let's imagine we have a specific S3 bucket called bucket 1, and you want to prevent anyone from uploading objects to it, regardless of their identity or permissions. So this resource control policy, RCP, explicitly denies the put object action on all objects in bucket 1, because we have bucket 1/wildcard in resource. So with this policy attached to the bucket, users can still read object, get object blah, 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 or list the bucket contents, but any attempts to upload or override object will be denied. So for example, a user trying to upload a new file to bucket 1 will be blocked even if their identity-based policies normally allow it. To compare these two, so SCP security control policy sets permission guardrails on identities within AWS organization, and it limits what IAM users and rules in member accounts can do by defining the maximum permissions available to them. And this type of policy don't grant permissions themselves. They only restrict permissions that identities can have and apply only to principals inside organization. RCP, resource control policy, on the other hand, set guardrails on resources across organization, and it controls who can access your AWS resources, including principal outside your organization. And this type of policy acts as a final permission boundary or resource access, overriding even overlay permissive resource-based policy attached directly to this to resources. And yeah, here we have permission boundary. So now we want to create a rule or user with broad S3 permissions, but we want to limit the maximum permissions they can ever have. So the permission boundary here allows all S3 actions on all resources, effectively setting ceiling on permissions. This means that when you attach this permission boundary to an identity and any policy granting permissions to that identity cannot exceed these allowed actions and resources. For example, even if a policy tries to allow EC2 actions, those will be denied because the permissions boundary restricts permissions to S3 actions only. And the last one, this is like extra type of policy because I didn't mention about it earlier. So the last one, let's imagine we have temporary credentials such as those from an assumed role or a federated user session, and we want to restrict what actions can be performed during that session. So this session policy allows the action list bucket only on the bucket name bucket 1, and only if the request is made in the EU Central 1 region. So what does it mean? Even if the user's underlying permissions are broader, during this session, they can only list the context of bucket 1, and only when operating in the specified region. So, for example, they cannot list buckets in other regions or perform other S3 actions like uploading or deleting objects during this session. So, to compare these two, permission boundaries limit the maximum permissions an IAM user or role can have at all times, and session policies limit permissions only for the duration of a specific temporary session. So provide a way to restrict permissions dynamically for that session without changing the identity's permanent policies. Okay. You might ask me, maybe or not, but I assume yes. How AWS evaluates permissions when you make an access request? So this slide doesn't show which type of policy is more important. It's not a hierarchy, but how the AWS check it to determine if allow or deny. So every request starts with a default deny. Nothing is allowed unless it's explicitly permitted. First, AWS checks the service control policy. If it doesn't allow the action, access is denied right away. Done. And next is the permissions boundary. If it's attached, it also has to allow the action. Then, we have identity-based policy and resource-based policy. So for the same account, either policy can allow access. But for cross-account access, both policies must allow it. And after that, if there's a session policy in the request, it must also allow the action. And finally, we have resource control policy, and it must also allow the action. So about resource control policy, I mentioned earlier, and about this, how it works, but yeah. And if any of these policies deny access, the request is blocked. So only if all required policies allow the action, access is granted. And let's walk through the grant, fine, grant access. And it is cross-account example. So on the left, we have account A, which contains a Lambda function. This Lambda function needs to access resources in account B. But we want to do this securely and with only the permissions it really needs. So yeah. How it works? First, in account B, we need to define a role called write access. And this role has permissions to access specific resources like an S3 bucket and an EC2 instance. Account A's Lambda assumes the role in account B. When it does, AWS returns temporary security credentials to the Lambda function. With these temporary credentials, the Lambda functions can now access the S3 bucket and EC2 instance in account B, but only with the permissions defined in the write access role. So here we have a simple use case regarding the real slide with cross-account example. But just a heads up, this is a simple example just to show you a little trick. So yeah, moving on. In account A, there's a free Lambda functions, and each of these functions has its own IAM role, like Lambda demo role 1, Lambda demo role 2, and Lambda demo test. I know that the one of them is different, Lambda demo test. Yeah, and each Lambda needs to access an S3 bucket that lives in account B. But since these are separate AWS accounts, we need a secure way to grant that access. So, okay, how we can set it up? So, account B defines a special IAM role called cross-account demo role, and this role has permissions to access the S3 bucket. The trust policy for cross-account demo role allows it to be assumed by the specific Lambda roles from account A. This means only those Lambda functions you see here can get temporary credentials to access the S3 bucket in account B. And when a Lambda function in account A needs to interact with the S3 bucket, it assumes the cross-account demo role in account B, and AWS STS provides temporary credentials, and the Lambda function uses them to securely access the S3 bucket. So account B remains in control of who can access its S3 bucket. And let's take a deeper look at this case. How much time we have? Okay. In account A, we have Lambda demo role 1 policy, Lambda demo role 1. And the most important part here is that policy allows the principal to assume a specific role named cross-account demo role in account B. What means it can temporarily take on the permissions granted to that role for cross-account access. The rest of part is an extra part to permit creating CloudWatch logs group in account A, etc. But it doesn't matter for this example. This is like an extra code which I did earlier for my tests. Okay, so let's walk through different approaches to defining trust policies for this case in account B. So these progressions, which I will show you, shows how to scale trust policies from simple to more flexible and maintainable configuration. And first, we start with a trust policy that includes a single role in the principal section. So this works correctly and allow that one role to assume the target role. Okay, so next, what if we need to allow more than one role? So adding 2 roles in the principal array also works fine. So we can specify multiple roles explicitly. However, when the number of rules grows and we expect to add even more in the future, like 15, 100, etc., constantly editing the trust policy to add each new rule becomes inefficient and hard to maintain, I guess. So to solve this, we may try using a wildcard in the principal to match a pattern such as all rules starting with a Lambda demo rule. But unfortunately, this approach results in an error because AWS doesn't accept wildcards directly in the principal field. Finally, the solution is to keep the principal more general for example, by allowing all rules from the account and then use a condition element with a pattern match to the role ARN. So this way we can securely allow any role matching the pattern without editing the trust policy every time a new role is added. But it's important to note that if a role's name doesn't match the pattern lambda demo role, it will not be allowed by this condition. So this method works well only if all relevant roles follow the naming convention. Like here we can see lambda demo test and access denied. So, okay, you might wonder why I've assigned identical roles with the same permissions to each lambda function in this example. So let me clarify. This is a simplified demonstration to highlight two key concepts. So first, it explains how wildcards can be used carefully in IAM policies, but they should always be limited as much as possible. So second one, it shows how conditions in policies help follow the rule of least privilege. For example, even if permissions look very open, conditions like AWS, I don't know, maybe source ARN or principal tag, etc., can limit access so that only certain resources or situations are allowed. So in real life, each lambda function should have a role made just for its needs. Sorry. Yeah. Okay. So we've seen some example how policies work, and hopefully you are now starting to get a sense of how powerful but also how complex IAM can be. However, it's easy to make mistakes, and sometimes those mistakes can have serious consequences. So this is why it's crucial to avoid common pitfalls like accidentally exposing your AWS keys. I know that is still common. I know you know. Okay, so now let's move on to some IAM best practices that can help you keep your AWS environment more secure. So yeah, here I put only a few most important IAM best practices. I know we have more, but yeah, maybe the first one is to enhance security in AWS. So I recommend, and AWS also recommends, to start by using IAM rules with temporary credentials for our applications, etc. So yeah, it's also essential to require MFA for all users, including the root accounts, and to also avoid using the root account unless absolutely necessary. So following the principle of least privilege is a key. And here, begin with restrictive permissions and only broaden them when truly needed. In addition, make it a habit to regularly clean up unused users and rules to reduce risk. And you can strengthen your policies further by adding conditions like MFA enforcement or restricting access by API address or region, as we saw in earlier slides. When delegating permissions, apply permissions boundary to limit the scope of what can be granted and manage permissions across accounts effectively using service control policy, SCPs. So SCP is really powerful type of policy, also RCP, etc. And finally, remember to rotate access keys regularly and store them securely to prevent unauthorized access. For example, you can set up automated reminders to change keys every 90 days and use use AWS Secrets Manager to keep keys encrypted and easily manageable. But of course, you need to remember that these are only a few examples, maybe a few general examples. So everything depends on your needs. But yeah, and here are a few key takeaways. So everyone, help yourself. And any questions? So I only suggest that because I see the time, and yeah, I only suggest that if someone has some question, comments, etc., also you can write to Xaba, and if you want, you can reach me out on LinkedIn. Here is my QR code to my account. So yeah, always I try to respond as soon as possible. So yeah, so feel free to reach me out on different way, and yeah, thank you.
Let's talk about some access control patterns with Cognito. So when we develop our applications, then we usually have some point of entry to the application, like an API gateway, if we apply REST type APIs, and we want to protect that point of entry. We want to protect our endpoint. And Cognito is exactly that service that helps us protecting those endpoints. In my earlier workplaces, as far as I can remember, when we discussed architectural patterns, and we mentioned Cognito, the opinions were well, quite ambivalent. So developers said that we don't really want to use Cognito because it's difficult, it's complex, it's hard to use, it has a learning curve. Absolutely. So Cognito has a learning curve for sure, but in my opinion, it has gotten much easier with the new UI. So I will start with a general introduction to Cognito. So what Cognito is, and I will mention the two components of Cognito. And then I will talk about how Cognito integrates with the API gateway. So there is a direct integration between Cognito and the API gateway to control access to an endpoint. Then I will mention some challenges and how we can address those challenges using Lambda triggers. And finally, at the end, we will have the questions and answers sessions. But before doing that, let me introduce myself. My name is Árpád, and I'm a champion AWS Authorized instructor, as well as an AWS community builder. I just started my 5th year a few weeks ago, and I regularly write posts and now create videos as well on serverless and the security topics. I most often about the combination of the two. And as Csaba mentioned, I'm also a Syntax Nebula instructor. So what is Cognito? Cognito is a serverless service, which means that we don't have to manage the underlying infrastructure. Cognito helps with authentication, authorization, and user management for web and mobile applications. And this is important. So we are not talking about access control to AWS services like S3. That's IAM. We just heard about that from Julia. Cognito is about protecting applications that we develop. Cognito has two components. First, we have the user pools. Cognito user pools is an Auth 2.0 and OpenID Connect compatible identity provider. It's a user directory, which means that it stores users' username, password. It manages sign-up flows, sign-in flows, forgotten password, multi-factor authentication. So, manages sign-in with third-party trusted identity providers like Google, for example. So that's user pool. Identity pools on the other hand, is different. Identity pools return temporary AWS credentials. So temporary AWS credentials for authenticated, that is signed in, trusted users and unauthenticated or guest users. Now this presentation, this talk will focus on user pools only. So I mentioned that Cognito User Pools is an Auth 2.0 and OpenID Connect compatible service. Let's see what that means and how it works. So let's say that we have a guest. Our guest is called Alice, and Alice booked a wellness weekend in a hotel. She deserves it. She works very hard, so she wants to spend 3 or 4 days in a hotel. So upon arriving at the hotel, first she goes to the reception and she will present her ID card. Now the ID card will have her name, date of birth, and any other pieces of information that the receptionist needs. Now the receptionist will check if Alice is actually Alice, and then if everything goes well, and of course the booking is paid, the receptionist will give Alice a key card, those plastic cards. Alice then will go to the elevator, she will go up to the 3rd floor, and she places the plastic card in the slot on the door. And if the card is coded properly, that means the card belongs to that door, the door will open, and Alice can enter the room. Now this is just a normal hotel check-in process. Cognito User Pools works in a similar way. Now we have a user, and our user is called, again, Alice. She goes to the reception, that reception is going to be Cognito User Pools, and presents her ID. In this case, her ID is username and password. The user pool will check if Alice's credentials, that is ID, are correct, username and password. If so, then the user pool will issue the plastic card, the key card, the access token. Then the application, Alice, through the application, will go to the door, the hotel door, will call the endpoint with that access token. And if the access token is configured properly, that is, it contains the needed properties, the endpoint API gateway will allow the request to proceed. Otherwise, it will deny the request. Now, one important thing here. The access token, just like the plastic card, has no information about the user. It's totally separated. So if I steal this card, I can enter Alice's room. So the identity is checked by a trusted identity provider. In our case, it's going to be Cognito User Pools. Now let's see the same thing in a bit more detail. So again, Alice signs in with Cognito User Pools, and the Cognito will issue 2 tokens. Most of the time, it will issue 2 tokens. First, the access token. We already talked about that. Now, this is the OAuth 2.0 compatibility. And it also issues an ID token. And the ID token is the OpenID Connect compatibility. The ID token contains information about the user. The access token is for controlling access to endpoints. The user pool will return these tokens to the application, and the application will call API gateway with one of these tokens in the authorization header. Ideally, that's going to be the access token. But API gateway can also sort of handle ID tokens. But in this case, API gateway only checks if the token is valid. So if it's not expired, it hasn't been manipulated, it comes from Cognito. If we want to control who can access what, that is, if we want to control that Alice can access endpoint number 1, but she cannot access endpoint number 2, then we will need to implement additional logic with the ID token. We don't necessarily need to do that with the access token, and this is what we will see soon. Both ID and access tokens issued by Cognito are JSON web tokens, and this is an example for the access token. So here you can see the token use property. It says access, so that means it's an access token, and this is the key here, that property, the scope property. Now the scope property or claim has a string value, and as you can see, that string has multiple substrings. If the access token contains the substring that the API gateway endpoint expects, then API gateway will let the request proceed. If it does not contain the expected substring, API gateway will deny the request. But here's a challenge. That scope claim needs to be claimed in the request. What does it mean? It means when a user authenticates, that is the /authorized endpoint is called, then the request, the authorization request, must contain a scope property in the query parameter. So if we want Alice to have, for example, the tasks::read permission, then the request, Alice's authentication request, must contain the tasks read substring in the query string as the value of the scope parameter. Now, this is not a problem if we have like 2 scopes and 2 users. But what if we have a fancy to-do application where we have many scopes and we want Alice to have these 2 permissions, then we want to have Bob those permissions. We want our admins to have all of these permissions. So how will the front end, the client, know what to put here in the request? So we can handle that on the front end side, but in my opinion, it's better to delegate this responsibility to Cognito, because Cognito's job is to handle authentication and authorization. And we can use Lambda triggers for this task. Lambda triggers are just normal Lambda functions which alter or modify the behavior of the Cognito user pool. So as you can see, there are 4 types or categories for Lambda triggers, and inside those categories there are multiple options that we can do with Lambda triggers. We can customize welcome messages, we can create captcha challenges, find all the bicycles in the image. So those types of challenges. At whatever stage we connect our Lambda trigger to, Cognito will interrupt the authentication flow at that point. It will invoke the Lambda function. The Lambda function will do its job. It will return a value to Cognito, and then Cognito will continue its flow with that new value. Now let's see how it works on a diagram. So again, we have Alice, our user, and Alice is placed in the read tasks group in Cognito. So we can create groups in Cognito, just like we can create groups in IAM. We can do the same thing in Cognito, and we can put users. into those groups. So Alice is in the read task group. So she will enter her username and password. She authenticates to the user pool. And after that happens, after the user pool ensures that Alice is actually Alice, but before the tokens are issued, we can interrupt that process with a pre-token generation Lambda function. So at that point, Cognito can invoke that pre-token generation trigger function. Now that function, again, this is just an example. You can do whatever you want. This function connects to a database. In this case, it will extract the group information from the input, its read tasks, the group that Alice belongs to, and fetches the permissions, the scopes that belong to that group. The function will then return those scopes to Cognito, and Cognito then will put those scopes in the access token. Now, if the application and Alice through the application calls an endpoint which is protected by the read permission, API gateway will let the request proceed. Why? Because Alice is in the read task group and the read scope is attached to that group. But if Alice tries to invoke an endpoint that is protected with a write permission, she won't be able to do that because API gateway will deny the request because Alice's scope don't have the write permission. Let me show you that in the code. Yeah, it's written in TypeScript. Other programming languages do basically the same thing. The main part here is that the Lambda function, the pre-token generation Lambda function, needs to return the input event as well as a response object. And here, access token generation. So you want to modify the access token or influence the access token, and scopes to add. And here, in this array, we will list these permissions. So that's how Cognito will know that that it needs to add those permissions to the access token. Let me show you that in the console very quickly. So we are in the user pool. So I go to users, and as you can see, I have two users, Alice and Bob. Let's click Alice, and as we discussed, Alice is in the read tasks group in Cognito. Moving on to API gateway. Now the Studio application is still in progress. So it only has one endpoint, the task endpoint. And here we have a get and post endpoints. Now, if I go to the get endpoint, then we'll say that it's protected by a Cognito authorizer. So API gateway and Cognito works together in this case. And what API gateway expects is this string, that sequence of characters, to do API/tasks::read. So if the access token contains that sequence of characters, API gateway will allow the request to proceed. Now, quickly, let me show you the post endpoint. And this is very similar. The only difference is that it's protected by the write permission. So let's see that's application. So here we have Alice, and let me log in Alice. There we go. And here. Now the entire process has just finished. Cognito did the authentication check. The Lambda function has already run, and we'll see that these are the scopes in the access token. Because Alice is in the read group, these are the scopes in the access token. Let me just quickly show that to you. So I go to jwt.io, and there we are. So this is token use access, and here, this is the scope that we need, that the API gateway will need. So if I head over to the tasks menu, and I click the Get Tasks button, which is connected to the Get endpoint, then I expect it to work, because Alice's access token contains that claim. But if I click the Create Task button, which is connected to the Post endpoint, I expect it to fail because it's protected by a write permission, and Alice's access token does not have that. So I go back to Tasks, Create Task, and indeed, API Gateway declined the request straight away. It does not even let it go to the backend. It will just cut it off immediately. So that's Alice, and let's quickly sign in Bob, and let's see what happens to Bob. Now quickly, let me show you Bob in the users. Now Bob is part of both groups, read task and write task. So we can have users in multiple groups. So the Lambda function can handle that as well. And as expected, Bob's permissions are both read and write. So here I expect that both endpoints will work, and indeed. So this is one way that we can configure Cognito and API Gateway to control access to endpoints based on users and user groups. So that's about it, what I wanted to share with you today. And are there any questions?